The next question which we have in hand is, we are given with an expression 1 plus x square whole square into 1 plus x whole power n is equal to summation ak x power k, where k is ranging from 0 to n plus 4. And we are given with the fact that a1, a2, a3, they form three consecutive terms of an arithmetic progression, that is a1, a2 and a3 are in AP. Therefore, we need to find the value of n for this condition to be satisfied and this expression to be satisfied. Now, in order to proceed with this problem, what we first do is, we open the brackets and write the LHS more clearly. What we get is 1 plus x power 4 plus 2x square into the expansion of 1 plus x power n, which is equal to nc naught plus nc1x plus nc2x square up till ncn x power n. This is the most basic and the most general expansion in the chapter of binomial theorem, which all of you should remember. Now this expansion we would put here. We get nc naught plus nc1x plus nc2x square plus nc3x cube, going in the similar fashion up till ncn x power n, which will be equal to, we put different values of k and write the expansion which is present in the right hand side. We get a naught x power 0 plus a1 x power 1 plus a2 x power 2 plus a3 x power 3, going in the similar fashion up till an plus 4 x power n plus 4. Now it is given in the question that a1, a2 and a3, which are the coefficients of x power 1, x power 2 and x power 3 respectively. This a1, a2 and a3 are the three consecutive terms of an AP. So the AIs in which we are interested are a1, a2 and a3. So we need not care about this a naught and the rest of the AIs. We just need to care about a1, a2 and a3, which are the coefficients of x, x square and x cube respectively in the right hand side of our expression. So what we do is, we just need to care about the coefficients of x, x square and x cube in our LHS. We rewrite the whole expression again. We will get 1 plus x power 4 plus 2x square into 1 plus nc1x plus nc2x square plus nc3x cube, and we need not write the further terms because they are useless for us. Also, this is equal to a naught x naught or a naught x power 0 plus a1 x1, or rather a1 x power 1 plus a2 x square plus a3 x cube, and we need not write the other terms because even they are useless for us, because we are interested just in the coefficients of x, x square and x cube. So coefficient of x in LHS is nc1x, when multiplied by 1 we will get the coefficient of, or the term which will be containing x. We can see that no other term will give us x term, hence the coefficient of x in LHS will be nc1 into 1, which is equal to n. On comparing the coefficient of x in LHS and RHS, we get n will be equal to a1. This is the first equation. Now coefficient of x square in LHS will be, we see when this 2x square get multiplied by this 1, we get a term of x square. So 2 into 1 will be one of the coefficients. We will see whether there is another coefficient or not. There is nc2x square, which when multiplied by this 1, we get another x square term. So there is nc2 into 1. We will check whether there is another coefficient of x square or not. We can see all the other terms are greater than x square. They are x cube, xe power 4. So there is no more coefficient of x square in the LHS. So we compare the coefficient of x square in LHS to the coefficient of x square in RHS, which is a2. This is our second equation. Now the coefficient of x cube in LHS is, we see when this 2x square get multiplied by this nc1x, we get x cube. So the coefficient will be 2 into nc1. Also when this x cube term gets multiplied by this 1, we get x cube term. So nc3 will be another coefficient. We'll see, or we'll check whether there is another coefficient of x cube or not. This x square cannot generate any coefficient of x cube because there is no term of x in this bracket. So this is the overall coefficient of x cube in LHS. On comparing the coefficient of x cube in LHS with the coefficient of x cube in RHS, we get is equal to a3. This is a third equation. So what we have is n equals a1, 2 plus n into n minus 1 upon 2 is equal to a2, and 2n plus n into n minus 1 into n minus 2 by 6, which is nc3, this is equal to a3. Now what we are given with is a1, a2 and a3, these are in AP. So 2a2 is equal to a1 plus a3. So what we get is 2a2 is 4 plus n into n minus 1, it is equal to a1 plus a3. a1 is n plus a3 is 2n plus n into n minus 1 into n minus 2 by 6. So now we can very clearly see we have got an equation in n which is equal to n square plus 3 is equal to n, or rather 3n plus n into n minus 1 into n minus 2 divided by 6, or rather this was n square minus n, sorry, by mistake I wrote it as n square plus 3, actually it was n square minus n plus 4, and this is equal to 3n plus n into n minus 1 into n minus 2 upon 6. On simplifying we get the cubic n cube minus 9n square plus 26n minus 24 is equal to 0, and on solving this cubic we get n equals 2, 3 and 4, which is our final answer.